Today's talk is going to be called Micro MPX. This first comment is kind of broad. I probably should have put it in more detail. The broadcast infrastructure is actually all about data connectivity. To say that it's all about connectivity, it's always been about connectivity. There used to be hundreds of wires and cables going all over the place in the studio, out to the transmitter, within the transmitter site. But today, when you think about broadcasting, and I realize our topic here is conventional broadcasting, AM, or in this case, FM. Broadcasting is really about data movement, data transporting, and connectivity. And so really what we're going to do today is talk a bit, we're going to kind of zoom in a particular area that has a need for data connectivity with probably one of the most critical signals within the FM plant, and that is the composite signal that ends up in the transmitter. All of this actually was made possible. My late partner, Steve Church, along with another one of our colleagues, Greg Shea, they're the fathers of what you now know as AES 67, but it started off as audio over IP. We call it live wire, but and in a way we're kind of honored that this has worked its way into a standard. To be able to have all this connectivity utilizing a network and IP is actually pretty special. And the outgrowth of this really comes from Steve's background in telephony. Steve had studied the intricacies of voice over IP many, many years ago, long before it really got into the commercial sector, and started thinking about how can we get this into a broader range with respect to the audio signals and spectrum. And so the concept of audio over IP, grew. And actually that development was probably at least a 5-year gestation. So what we're now able to do is to focus in more narrowly in the area of the transmission path, and in this case, the MPX signal. The whole discussion about how to transport and manage the composite signal, for a long time we basically had it in the analog realm. We had composite signal, or what we've always called the composite signal. You could either go directly from the audio or stereo output of the stereo generator, for those of us that remember the days of the standalone stereo generator box, into the transmitter, and then later on, and I realize he's a competitor, but hats off to Bob Orban, who was the first to put the stereo generator in the audio processor. And how many of us had that 6-foot piece of RG58 that went from the output of the Optimod into the exciter, and then eventually being able to, transport it over an analog STL system. And it seemed like forever to be able to get the ability to transport the composite signal in the digital domain. Many years ago, at what was at the time still cutting edge technologies, myself and some colleagues, we came up with a way to do it utilizing a host of serial cables, and it never really caught on because we made it work with one exciter, and it basically became let's say an ongoing debate, if you will, about there's no need to do this in the digital world. But it was if I think back on it, it was 3-4 years ago. It was some of you may remember this story. I was talking with Jeff Weldon of Nautel earlier. It was the concept of what is now known as MPX over AES was actually born at this conference. And the quick story is, the night before, Chuck Kelly, Jeff Weldon, myself, and a couple other guys from Nautel, we went over to this wonderful Italian restaurant here called Vinsanto, and we were talking about what would it take to be able to get the MPX signal, digitally from point A to point B. And they had mentioned that they had just introduced an exciter that would accept an input signal that was sampled at 192 kilohertz sampling. And I said, guys, if you can do that, I can give you the composite signal, because we had a way of being able to get the stereo generator output down to 192 kilohertz sampling. And we said, well, AES will give us that ability. So the whole concept of MPX over AES was literally born the night before this conference started. I want to say it was 3 or 4 years, probably about 4 years ago. And then together we showed it running at the next NAB. And the funny thing is that, you know, both companies said, you know, this is one of the reasons why I think we work well together. You know, we're kind of competitive, if you understand. And the idea was we were going to keep it among ourselves for about 6 months. Well, within an hour of introducing that technology at NAB, all the other audio processing guys went running to Chuck and said, how can I get this tech? Meanwhile, all of Chuck's competitors came running to me within the hour going, how can we get this tech? So we made the decision there on the floor to open it up, and we did, and then the whole MPX over AES method basically became a reality. So today, like I said, we're going to drill down here a little bit, and so our discussion is not only about the composite signal, but actually about the transom of, you know, and not really a debate, but there are ways of doing it in a linear or a data-reduced method. Obviously, or at least from my vantage point, this has been a natural progression. At that same convention in Las Vegas, while we were getting a lot of, you know, pats, you know, attaboys and pats on the back about, you know, finally somebody figured out a way to do it. There's, you know, it's something that's standardized. You know, we basically could plug and play. I had a number of people that approached me and said, and how can we do this over a network? Well, you know, my eager beavers within the Telos Alliance were like, well, you know, Frank, we can do this over LiveWire and blah, 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 but it's going to suck a lot of bandwidth. So it took a few years, giving it some thought. We came up with a method, but one of the aspects of benefit comes about, and it was a number of actually international broadcasters that approached us, where they said, if there's a way, you know, on one hand, it's great to have a direct point-to-point connectivity method, and the MPX over AES transom allows that, provided you have the bandwidth, if it's going to be over a long haul. But I do know that internationally there are a lot of instances where a point-to-multi-point scenario is needed. The example being, in Europe, what we call a network here in the States, we think of like NBC, ABC, CBS, Fox, and that kind of thing, where you have, you know, this signal that's leaving, you know, a network center and going off to the affiliates. In Europe, you have a lot of broadcasters that call themselves a network, but they're basically a radio station that's distributing their signal all over the country to a bunch of low-power transmitters. France is a perfect example. You know, France is probably, what, 1.5 times the size of Texas, if I'm doing rough back-of-hand calculation. Yet, it's easy to, you know, there's these large networks there, one's known as Energy, Skyrock, Fun Radio. They may have 500 little 500-watt, 1,000-watt transmitters interspersed all over the country, covering all the provinces, so that their signal is covering all of France and then some. In their desire, they want to be able to have that one signal be processed in Paris and then get distributed all over the country, and know that it's going to basically be a mirror transmission if it's, you know, in Lyon, which is in the north, or Marseille, which is in the south, or something of that nature. So in that instance, there's a need. We're starting to see a need for that here in the United States, where with synchronized transmissions and things of that nature, being able to have a point-to-multi-point install does make sense. Now, as I mentioned, the linear implementation would consume extreme amounts of bandwidth. It's greater than 3 megabits per second. So if you know, we can get it digitized and we can get it in a network format, but you know, most of you probably aren't going to have the data bandwidth, especially a pipe from point A to point B, or a point A to, you know, B through Z to get that distributed. So what we actually need is we need to come up with a very efficient data payload, and that's where the challenge comes into play. What Micro MPX does is it slashes the amount of bandwidth needed by nearly 84% to a remarkable 320 kilobits per second. All right, the technology is compatible with existing digital STL systems. be it RF or data link, and lower cost data links, can be routed directly into the transmitter, provided that the transmitter device has a decoder where we can take the encoded signal and turn it back into whatever data format that the modulator in the transmitter is going to need. At this time, we've been collaborating again with our friends at Nautel. We showed this as a work in process a number of months ago in Las Vegas, and as part of that collaboration, our friends at Mosley, we set up a scenario where we had everything running out of our exhibit, and then through a data link, it went over to Mosley, who were running it through one of their digital STL systems. We were using, I think, 320 kilobits per second, and it went over a cable in RF form to a receiver at Nautel, where out of that, the data went into a software decoder, and from there it handed off the MPX signal to the transmitter at Nautel, and we had it running the entire show. Now, to make this happen, obviously, we need a codec. So at the onset, I was joking around a little bit about being politically correct and stuff. Yours truly, coming from the audio processing background, and somebody who's probably shared quite a number of debates about peak control and what can degrade a signal from point A to point B, and the whole aspect of audio codecs. I've basically been a proponent, up until now, about not utilizing a codec after an audio processor. And the reason being is that, generally speaking, even at high bit rates, an audio codec can be sonically degrading to the processed audio. And the other big gotcha is that what we had noticed is that the performance of the codec would undo some of the peak control that had been previously done by the processing in the audio processor. Well, lo and behold, I have to say that a couple of young colleagues within our organization basically sat me down and said, Frank, we've been doing a lot of research, we've been doing a lot of work on a new codec design. And they said, we agree with your view about processed audio going through a codec, because what your experiences has been that you've been utilizing a loss-based codec, and loss-based codec, we think of MP3, AAC and things of that matter, where audio goes into the encoder does its magic, chops up some of the audio, throws some of it away, sends it to the other side. The decoder basically says, oh, here's what it is, I'll do my best to reconstruct, and then it hands it off to whatever the next piece is in the chain, be it, if it's a remote, or in the case of, backup STL link, gets into the exciter or what have you. What I had always observed in those situations is that the audio at the output of the decoder, there had been some aural degradation, not radical, but enough that, I was able to hear that. But more importantly, the peak control was undone to the point of, 10, 15, sometimes 20% overshoot. Now, you think of 20% overshoot in FM, that's 2 dB that you've got to compensate for in total modulation. And I don't know of any, I know program directors that if you're down 1/10 of a dB, your phone's ringing. So you drop the process signal by 2 dB, or the output by 2 dB, somebody's going to, there's going to be some trouble somewhere. So what my guys did was they sat me down and they said, Frank, we've done some in-depth study and research, and we've actually designed a whole new codec that utilizes something that they call a predictive analysis method. Yes, data is thrown away, but the way it is done, instead of throwing the data away and it's gone forever, there's enough information about the data that was removed that actually goes along as metadata, so that I don't want to say that it's a lossless codec. It's close to being a live lossless codec. But what is actually able to do is that when they reconstruct everything on the other end, the peak level is remarkably on the money. You know, we do employ a little bit of safety control to make sure that there's, or I should say inaudible safety control to make sure that peaks are retained. But, you know, that was item number one. Item number two is that in doing a lot of A/B listening of the codec to the source, it was deemed, you know, back in there was something called the mushra tests where they would do all this codec comparisons. This was falling in the 4.5 and higher range. And they did some testing at a university in the Netherlands. So upon doing some tests of our own and listening, I had to say that I had to change my tune. So again, there'll be no locker room talk. There'll be no endorsements of any, although I do have to say that since the Cleveland Browns are so bad and their quarterbacks are getting knocked out left and right, I'm wondering if both presidential candidates could be a quarterback for the Browns, and then they'll both get knocked out in like the first quarter. And then, you know, thank you. Kirk, isn't that amazing that the applause has to do with, you know, about me knocking the two supposed people that are running for president? In any case, I had to, you know, I have to stand up here in front of all of you and say that my tune has changed with regard to how we deal with processed audio, and in this case, the composite signal that's already been processed and well filtered being passed through a codec. Now, you're probably out there sitting there saying, okay, Frank, there's a codec involved. Where does the other shoe drop? What this codec also employs is it employs some masking, noise masking, to help hide some of the artifacts. And basically, what ends up happening here, and this is, let's see, there is a pointer. Don't shine in your eyes, Frank. Okay. You let them out. Okay, there we go. So, over here, this here is like a source signal, a tone, if you will, all right? And over here is basically the tone, and this is like a different way of looking at a spectrum, you know, where your predominance of the signal level is here, and as you move out, you're getting closer to the noise floor. Same thing here. As you can see, there's a little bit of noise. This is the coding artifacts here, and it's represented here. This has nothing to, by the way, guys, this has nothing to do with peak levels. If you're thinking, Frank, you know, that's modulation, you know, what the hell are you talking about? So basically what ends up happening is this noise level is so far down, it's suppressing and covering over the artifact, you know, what would be perceived to be the coding artifacts. So what we do is we basically are trading off the ability to have a data-reduced signal, yet at the same time, we're going to accept a little bit of noise into the system, but it's so far down, it's not going to be perceivable. And basically, these plots are from two different parts of the design. This is an early part of the design, and as you can see, all right, we'll try this again. Yes. As you can see, at a bit rate of, this here is artifact level, and then this is bit rate. And as you can see, in an early design, the artifact level at 384 kilobits, or even 320, we're down about 10, 20, but a little over 40 dB. As we move forward, and this, and by the way, they've further refined this. So these slides are as of May of this year. You can see they've dropped it another 20 dB. They're telling me that they can get the thing running at about 320 and maybe lower, and these numbers will go down even further. So basically, you know, we're trying to put it all out there insofar as what the benefits and some of, let's say, the hurdles or challenges that we've needed to get ourselves around. At the end, and I put these first two items in here in bold because, again, and this is what I told our team, we can have zero overshoots, you know, meaning of what goes into the transmitter, no oral artifacts, meaning that the codec is not to contribute any additional artifacts to the signal as we're passing it through. I realize, we could sit here and debate till the cows come home about artifacts and audio processing, and there's, we know there's no free lunch there as well, although I'm going to talk a little bit about some new algorithms we've been working on here in a few minutes. But we need the codec to basically be a mirror. So what's going in is what we need to have come out with respect to audio performance. And also, we need to have delay be as minimal as possible. Most of us know that in the case of utilizing a codec, sometimes we can get a high buildup in delay. And even though here, in the United States, delay isn't so much a problem anymore due to HD radio, or if you're running HD radio, you just kind of factor that in. But the delay on this is quite low. It's down in a few milliseconds. I thought I would put this up here just to give you an idea. This is at the output of the decoder, where I was able to take a look at the composite signal. This would be what we're handing off to the transmitter. And as you can see, the peak control is extremely precise. Actually, there's no overshoot at all. Now, some of you are saying, well, Frank, I don't see the pilot in there. Well, gentlemen, and I'll go into a little detail a little later on, something that is unique to the way we do a stereo generator now, and this is only within the stereo generators made by that company right there. We add the pilot. We don't add the pilot anymore. When you think about FM stereo, the whole thing about the FM stereo system is left plus right, 45%, left minus right, 45%, that's 90, and then you add 10% for the pilot. Well, new math. The way we do the FM composite signal, legally, L plus R, 50%, L minus R, 50%, yet we're going to stay at 100%. Why? Because we're embedding the pilot. The pilot in this signal is not riding on top of the audio. The pilot gets embedded. What does that mean? If in this signal, if I turn the pilot off, the audio stays at 100%. This is the same, this is analogous to running a normal, the theoretical FM stereo system out to 110% modulation. What has happened is that extra 10% that we've now embedded is 1 dB in loudness. We've given you legally. So it's 1 dB in loudness guaranteed. Now you might sit there and say, but Frank, 1 dB, I can't hear 1 dB. Right now, me speaking to you in an unprocessed environment, if they change the level on that mixing console by 1 dB, you're not going to hear a difference. You take a tightly controlled, compressed, dynamically controlled. I realize talking about compression. I don't know about you guys, but I hear the word compression. I think dynamic. Some people think about data. But you take a tightly controlled dynamic signal that's coming out of an audio processor, and you raise that output by 1 dB, that can be the difference between that button push in the car by the program director saying, that one's louder. So we have the ability, by doing this pilot embedding method, to deliver 1 dB in added loudness. Also, that's 1 dB in added loudness with no degradation to the audio. It's the same as if the government said, we're going to let all of you turn up your modulation by 10%, and the added audio benefit you're going to get is what you're going to get. So this is something that basically grew out of some, let's say, very, very friendly and jovial discussions between a young man who's of Swedish and Jamaican descent, and another old geezer who's of Sicilian and Italian descent, meaning Leif Clayson and yours truly. So when you read about some of our stuff that say, we are delivering 1 dB of added loudness guaranteed, that's the reason why. Also, that function works its way through this Micro MPX signal. Here's a couple of just pictures also, again, I realize we're going back to the lab. MPX spectrum, 100% modulation, a little bit of demodulated left channel under of up to, it should have been spaced there, sorry. A little bit of bleed, into the other channel, but also, as you can see, the RF spectrum is maintained as it should be. So, in keeping with how everything should be operating, the Micro MPX signal performance is what you would expect it to be, other than the fact that we're not having to utilize 3 megabits per second of data. It does support double sideband and single sideband for FM stereo. It supports RDS, and I already went into a little dissertation here for the pilot embedding, and it really is 1 dB louder. I have to tell you guys, it's pretty cool. You can have the mod monitor up, and have everything running, and you turn the pilot down to 0, and the modulation meter is still sitting at 100%. And you get all that for free. I think it's in the 1 or 2 upgrades back for most of our audio processors. With regard to the tech, you might be saying, well, Frank, this is all well and good. How soon can I have it? Yada, yada, yada. A couple things we have to talk about. There is still some work yet needs to be done. In the front end, I was talking about boosters and repeaters. There's the whole desire to have things time aligned. So they're working those aspects out now. Also time stamping, which is becoming, we're finding out to be somewhat critical with respect to, it also factors into the whole synchronization part for boosters and repeaters. I'm going to guess sometime next year. While we've got a lot of the tech going, the other piece is actually 2 parts. While we have ongoing dialogue with our friends at Nautel, it's being able to get the decoder piece operating as it needs to be operating in the transmitter. And also we know that there's people that are asking us, could they just have a box where there's basically, something that's coming out of the network going to a box, and then they can distribute the output either in a digital format or an analog format to go to like older transmitters and things of that nature. So there's still some of that on the drawing board within our little camp. And, so if any of you, this is something that interests you going forward, I would say sometime during the winter when, when the ice age is working its way from Canada all the way down through Ohio, call us up or send me email or reach out to some of our people, and we'll give you an idea as to where we're at with this topic. Okay, I thought I'd put up just a few visuals here. Basically, when we talked about being able to have the MPX over AES, this is basically the idea, which is doable right now. As you can see, it's basically an AES cable that's coming out of the stereo generator in the digital format. It's being plugged, what should be going into the modulator stage of whatever transmitter, and the sampling rate is operating at 192 kilobits or kilohertz. MPX over IP, this is doable. Again, it's the same as before. The difference being is that this pipe right here needs to be a really, really, really big pipe. It is possible. There are some people that are willing to do it, but on the expense side, it gets up there. And again, this could even be, this could be all co-located, and you're doing it in the network environment. Although if it's in a co-located scenario, it'd be better to just go AES from the output of the processor into the exciter. Now what we've got here is you've got your output, and now we've got this Micro MPX signal here. It should say Micro MPX there. And now we're going to a router, and once we get it into the router, it's data, and we're moving it around as we would be moving around signals within your facility, if it's in the audio over IP environment or something of that nature. Actually be in the cloud today, probably not, but going forward, probably yes. I'm going to talk about the cloud here in a few minutes, but this here gives you an example as to the point-to-multipoint situation and scenario. And quite honestly, I'm not saying that, the example that I gave earlier about what we see in Europe with some of the networks, will that actually ever happen here? Don't know, but we do hear from some of our customers who want to know that they have that option available if need be. Could be for like some emergency situation or some other type of configuration that they may be contemplating in the future or something of that sort. But what it does mean is we can now take the one signal that's, as I said earlier, very critical, very needed, and not only have we now, a few years ago, come up with a way to get it from point A to point B in a digital manner, we can now even do it in a network manner. So what I thought I'd do, that pretty much covers the whole topic of the Micro MPX. And without going into super great detail on it, I thought I'd take the last few minutes here, since whenever I'm out and about, people are always saying, so what's going on with you guys? What else is happening? And I thought I would take that just to peer into the crystal ball here for a moment or so. And it's not really so much product related, but technology related, because after all, when you think about it, think about the last 20 years. Look at all the innovations, and Steve and I used to talk about. We used to have a phrase about talking about trying to come up with the next quantum leap. And 20 years ago, I remember us thinking that when radio happened, that was a quantum leap. And then when Major Armstrong experimented with FM, that was a quantum leap. And then television, that was a quantum leap. Color television was a quantum. Now, remember, all these didn't happen like in succession, like, year one, year two. I mean, there were, the gaps in between all of these changes were huge. I mentioned color television, then FM stereo, and but in the last 20 years, we've seen quantum leaps that have, matched or exceeded that in many ways. I mean, the ability to, we all have some form of this, and what this does is, to be able to walk down the hall and, if you watch television from anywhere in the world is although 20 some years ago, if somebody would say that, in 1988, I would start a business and take on the audio processing giant that had 85% of the world marketplace, I would have said, you are effing crazy. See, no locker room talk. Yet here we are. So innovation, my brethren, innovation never sleeps, at least from my vantage point and that of my colleagues. I know later on today, Kirk has got some exciting things to talk about, and as a matter of fact, I think this week there's a handful of us out and about, telling our story. Just not being able to tell a story as cool as Bruce Springsteen's Born to Run book, but what the heck. The future is the cloud. Whether we like it or not, the future is the cloud. I realize, if I would be sitting out where you're at and somebody said that to me, I'd be saying, whoa, now wait a minute. I got a nice little facility, I got a nice little infrastructure, and it works very well, thank you very much. And I remember when I was on your side of the table, embracing change at times for me was not very easy. And I'm not saying that all of your lives are going to be changed by the cloud, but it is out there on the horizon. In the not too distant future, you will have the ability to basically look into the cloud and create a broadcast facility out of thin air. If you're wondering, are we working on that? Yeah, we've been working on that for quite a while. Does that mean that the boxes we make and the stuff that Jim Armstrong will be able to show you later today is going to go away? No, that'll never go away. Because I know there's some of you out there that are going to say, Frank, I want a box, if it's for radio or for television or webcasting or what have you, you want that box, we're going to make it for you. I guarantee you that. As long as I'm still involved with this organization, that'll never change. But I also know, and this is a true story, 2 years ago, about this time of year, I was over at the BBC, Radio House in London. And the BBC has been a very friendly customer to our organization. And I'm talking to the Director of Engineering for radio. There they have a building called Radio House and one called Television House. The gentleman in Radio House said, Frank, we love your company, we love your processors, we love blah, blah, blah. He rattled off the product line. I went, pretty cool. He goes, and then, sometimes our British friends like to show their humor in a, let's say, offhanded kind of way. He said, but I'm not going to buy another box from your company ever again. And I'm sitting there thinking, okay, time to call Clemenza, from the family and take care of business here. What they did do, and this was very enlightening because, the BBC has been very, very older world, very, I don't want to say stodgy, but, for them to take a big step, has always been a big thing. So they took us on a tour, and underground, under the building, was this old musty area, which was the transmission area. And it was rack after rack after rack of processing and routing switchers and codecs and all you can name. And he turned to me, he goes, I'm not going to buy another box from you because I want you and your people to put all of this in applications that will run on this server over here. And I want it to be codecs. And that's when it hit me. It's going to go into the cloud. So if the BBC is willing to look at the world that way, others are going to do as well. And there will be a day where somebody could be sitting right here and go, Foti's really boring. I need to hook up a new mixing console in Studio 4. And you'll go on your computer and you'll go into the cloud and you'll hit a few keystrokes and you're going to have, in the same way that I downloaded Bruce Springsteen's book to my Kindle, the moment it came out, you'll be able to configure some broadcast facility and it'll show up automatically. That's part of our future. And that's something that, we're working very hard on. And everything that we do is going to be somehow, some way tied into that. Now somebody might say, well, if you're saying all this, aren't you tipping off, the people you compete with? I mean, if they're not already taking a look at this, their days are numbered. And I think in the broadcasting world, I realize you guys are competing with people that are able to transmit to this thing. On Friday nights, yours truly plays sportscaster because my high school, Wycliffe High School, me and another guy, we webcast the Wycliffe Blue Devil football games because we have added bandwidth that doesn't get used down at Telos, and we put it out to the world. And we have a lot of fun with it. The school gets benefit from it, so everybody wins. So if I'm able to do something like that, radio and television will be able to do. And when I say television, the reason I put the emphasis on television is already moving into this quite a bit, as well as Hollywood. We see a lot of this going on in Hollywood. Obviously, since yours truly hails from the land of audio processing, myself and my contemporaries, we're constantly working on various things. This year, if the gang at work like to call me the boss, and I always say that Bruce Springsteen doesn't work there. But if I am Bruce Springsteen, my Clarence Clements is Cornelius Gould, and who's also, they were both the big man. So the big man and I, we're continuing to push the envelope and bar with respect to signal processing. And in every domain, actually Friday of last week, Corny took me aside and he showed me some new algorithm that he's applied for final look-ahead limiting for data reduced audio. And the way he was able to remove even more intermod distortion from the limiter enabled the audio running at a low bit rate to sound amazing. I mean, he literally put up the stream he had, and then he put up a whole bunch of other network streams, that were using our stuff, by the way, and other people's stuff, and the advancement in the sonic performance was striking. It was my jaw dropped, to put it mildly. So, this is something that is, again, as long as I'm involved with our organization, and I intend to be involved for quite a while yet, gang, we're going to be pushing the envelope as hard as we can. Processing This next item is something that's still very topical. And it combines audio processing, watermarks, and intelligence. Last year, somehow, our little company somehow, okay, I guess we were guilty, got involved with trying to make the Nielsen PPM system work a little bit better. If any of you ever look on ESPN's website, they run a human interest article every day called 538. One day last summer, I happened to look on that because being a diehard Cleveland fan, maybe this is our year for the Tribe. The 538 did a whole article about ratings, watermark, PPM, and right in the middle of the article was a picture of our product. It shocked me because, I mean, you know, modestly speaking, we've been able to be nicely covered by our trade press, but when the mainstream gets into it, you know you've poked the bear. And we continue to poke the bear. And the reason I'm bringing this up is we were just completing some work on a new monitoring system, off-air monitoring system for the watermark system. And we've learned that even with the enhancements that we're able to put into processing and the Voltaire product, there's still some added stuff that can be done. Because we know that Nielsen's last update, which is called EC-bit, at times can be overdone. I don't know about you guys, but I can hear it like that. If I'm listening to a ball game, the Indians affiliate in Cleveland, when the guys aren't talking, I can hear the watermark sitting on top of the crowd noise, and it's annoying as all get out. So what we're doing is we've created an off-air monitor that's got some intelligence that can say, hey, you know, the watermark's really good right now. Oh, by the way, it's being injected way too much, so we'll bring it down to a manageable level, which will improve the oral performance. Oh, there's still some holes in this talk show. Maybe we need to goose it just a little bit more. Because at the end of the day, it's all about seeing to it that your broadcast signal is getting the proper credit that it deserves. I've been privileged to what some broadcasters pay these rating services to be in the ratings, and it's pretty crazy. So if you're a broadcaster, you want to know that whatever data service you're utilizing for ratings, you want to be able to know that you're getting the credit that you deserve. And I'm not saying in an unfair fashion, in a fair fashion. And you know, we now have well over almost 2 years worth of data to know quite a bit about this. I see I'm running out of time here. The last thing I want to mention is there has been some work done about metadata and broadcast audio, dealing with processing and other things. And we've been working on the front end of that too. So I think I say thank you. If any of you have questions, I'm happy to entertain them. As always, you guys are a great audience. I'll be here through the luncheon, and then I got to make my way back to Ohio. By the last ad hoc story, normally when I've done this thing, yeah, the Goomba there doing the news, that's about 1976 at WELW Radio in Willoughby, Ohio, and then some fun times. And then luckily that radio station is still around. Quick ad hoc story, and we'll get to questions. Normally I would fly up and fly back. Last night, because of all the flight changes, I was booked in to get in here about 10:30 last night by way of Chicago. And then today it's like Cleveland, no, here to Charlotte, Charlotte to Cleveland. I got a busy day tomorrow. And for some reason, on my way to the office yesterday, I said, you know what? Something doesn't feel right about this travel schedule. So I made the decision at the last minute to drive, which I did. I got here to the hotel last night and learned that 3 of the 4 flights were already canceled. So I'm glad to have been here. Thank you again. I understand we've got some questions. I'm happy, yes.
Is this working? Okay.
It is now.
Have you considered the applications and implications of certain aspects of multiplex, µMultiplex on EAS and iPOS, and solving some of the problems of them, you know, how they handle the network?
That's an excellent question. Personally, I have not, but I'll be happy to make note of that and get it down on the to-do list and to look in it. I will say on the EAS front, I have been asked to take a look at why the EAS system doesn't behave as consistently lately with the enhanced watermark system. So I have done a little bit of work in that area, but to your question, I'll make a note of that. Yes?
Yeah, Frank, your embedded pilot, do you have to talk to the FCC about doing it that way, or?
Nope.
I mean,
And here's why. All the government cares about, if you're clipping the pilot, the government's going to be all over you because you're going to be shooting, you know, spurs and stuff up and down the baseband. But the way that we do it, as a matter of fact, there used to be a composite clipper. Some guys would composite clip where they would clip the pilot, and it would create the waveform like you saw that. But on your mod monitor, you would see the pilot modulating like crazy, and it would be modulating in a negative fashion. In this case, you put the pilot up, it doesn't move at all. The spectrum is beautifully clear. I mean, you know, in and around the pilot, the noise levels, you know, theoretical, is like 96 dB noise suppression.
so if you're looking at a mod monitor, you're seeing pilot modulation.
With the embedded pilot, no. The pilot is rock solid at 8, 9%, whatever you want.
Oh.
And by the way to do it is so simple that I can't possibly tell you. And the reason being, I in my home, I live with 3 members from the Sopranos television show, my 3 cats. The one is Silvio Dante, and it's his algorithm, and if I told you, I'd be sleeping with fish.
Any other questions? Okay, excellent. Thank you very much.
Thank you
Frank.
very much.